Open your fridge and imagine trying to explain it to a human from 50,000 years ago. Milk from another animal, kept cold inside a glowing cupboard. Fruit that appears in winter. Meat cut into tidy pink rectangles with no visible evidence that it once had opinions. And a sauce that remains edible until 2028. So what did ancient humans actually eat? The short answer is almost anything they could safely chew, digest, catch, dig up, crack open, or steal from something with larger teeth. There was no single ancient human diet. There was a moving menu controlled by geography, weather, technology, luck, and the recurring biological suggestion known as hunger. We often imagine an ancient meal as a slab of meat beside a fire. This is partly because meat leaves excellent evidence. Bones survive. Stone tools leave cut marks. A root quietly decomposes and contributes nothing to the documentary record. Archaeology is therefore a little like reconstructing a party from the objects still on the floor. Bottles suggest drinking. A single sock raises questions. The salad has vanished completely. Also, ancient humans covers several million years, multiple human species, and nearly every environment from tropical woodland to frozen grassland. Asking what ancient humans ate is a bit like asking what modern people eat. The answer could be rice, seal, mango, goat, seaweed, or cereal consumed directly over the sink. Our ancestors lived inside nature's badly stocked supermarket. It had no shelves, no labels, and no opening hours. The fruit aisle disappeared for months. The meat aisle could run away. Some products were underground. Others were poisonous unless processed correctly. A large portion of the inventory was defended by horns, shells, thorns, stingers, or a general unwillingness to become lunch. To rebuild this menu, researchers combine several kinds of clues. Animal bones can show cuts from slicing away flesh, or impact marks from smashing them open for marrow. Charred seeds and plant fragments sometimes survive around hearths. Tools can preserve microscopic residues. Teeth reveal wear patterns from chewing different kinds of food. Chemical isotopes in teeth and bones can show where someone sat in a food web, or whether their diet depended more on certain categories of plants and the animals that ate them. Then there is dental calculus, which is hardened plaque. Tiny grains of starch and plant material can become trapped inside it for thousands of years. This means a substance currently removed by a hygienist with visible disappointment can become a prehistoric meal record. If you enjoy good explanations accompanied by art of uncertain structural integrity, subscribe and we will continue examining humanity's crumbs. These clues do not produce a perfect shopping receipt. Tooth shape tells us what someone was equipped to eat, not necessarily what they ate on Tuesday. Microscopic wear may reflect a relatively short period near the end of life. Isotopes can reveal broad dietary patterns, but often cannot distinguish between eating a grass and eating an animal that ate the grass. Calculus proves that something entered the mouth, although occasionally that thing may have arrived as smoke, dust, or food processing debris. The best answer comes from stacking the clues together. For the earliest human ancestors, plants were probably a major part of the diet. That could include fruit, leaves, flowers, seeds, nuts, bark, and underground storage organs such as roots, bulbs, tubers, and corms. Those underground foods were especially useful because they did not sprint away. They could also remain available when more glamorous foods disappeared. But digging them up cost energy. They might be tough, bitter, fibrous, covered in dirt, or protected by toxins. Many wild plants also looked nothing like their domesticated descendants. There were no enormous bananas designed to fit politely into a lunchbox. A useful root might resemble a wooden ankle and require determined chewing. This is where tools mattered. A digging stick could reach buried food. Stones could crack nuts and seeds. Cutting and pounding reduced chewing. Grinding turned stubborn plant parts into something closer to dinner. Food processing was effectively an external set of teeth, which was convenient because natural selection takes a very long time to install new kitchen equipment. Animal foods also became increasingly important in human evolution. By at least 2.6 million years ago, animal bones show clear evidence of stone tool butchery. Early humans were cutting meat from carcasses and breaking bones to reach marrow. They may have hunted some animals, scavenged others, and taken whatever opportunities the landscape provided. Meat offered concentrated protein and nutrients, while marrow and fatty tissues supplied valuable energy. But acquiring them was unreliable and dangerous. Hunting a large animal can produce an enormous return. It can also produce several hours of running followed by no food and a fresh understanding of why the animal was selected for speed. The tidy, modern distinction between desirable cuts and everything else would have made little sense. A carcass was a package of muscle, fat, marrow, organs, skin, connective tissue, and occasionally brain. Soft organs rarely survive archaeologically, so we cannot reconstruct an exact organ-by-organ menu. But people processing whole animals were clearly not waiting for someone to remove the bones and place the useful section on a foam tray. Small animals mattered too. Birds, eggs, rodents, reptiles, fish, shellfish, and insects could all become food where they were available. Insects are especially difficult to detect because they leave very little behind. But humans are flexible primates. Many recent foraging societies eat insects, and our closest primate relatives do as well. Termites, grubs, caterpillars, and honey could provide useful calories without requiring a dramatic duel with a mammoth. Honey deserves special attention because humans are extremely interested in concentrated sugar. Finding a hive meant discovering a box of calories guarded by thousands of tiny flying needles. This did not prevent people from wanting it. It merely added equipment and consequences. Near rivers, lakes, and coasts, the supermarket changed again. Fish, shellfish, crabs, aquatic plants, seabirds, and marine mammals could offer rich and sometimes predictable resources. Shell middens, fish bones, tools, and chemical evidence show that many later human groups used aquatic foods extensively. In colder regions, plants might vanish for long periods, pushing people toward animals and stored food. In tropical environments, fruit, tubers, nuts, honey, and small animals could remain more important. Even closely related humans ate differently. Neanderthals living in cold European environments often show strong evidence of large animal consumption. But they were not simply permanent steak machines. Plant remains preserved in Neanderthal dental calculus include starches linked to foods such as wild barley, legumes, and date palms. Some starch grains also show signs of heating. The famous cave resident was apparently capable of eating both large mammals and something resembling a very rustic grain bowl. Fire transformed the menu. Secure evidence for hearths goes back at least hundreds of thousands of years, with the earliest widely accepted examples around 790,000 years old. While possible cooking may be older, heating food can soften tough tissues, release more usable energy, kill many pathogens, and reduce toxins in certain plants. It also makes chewing less of a full-body occupation. Cooking did not instantly replace raw food. Fire requires fuel, maintenance, and control. People probably used a mixture of raw, roasted, pounded, dried, smoked, and later boiled foods, depending on time and technology. The ancient kitchen was not one invention. It was a growing collection of ways to persuade difficult objects to become edible. The most important ingredient, however, was seasonality. A person might eat berries heavily for several weeks because berries were everywhere. Then the berries ended. Herd movements changed access to meat. Rain brought certain plants and insects. Dry periods made animals gather around water. Coastal foods changed with tides and migrations. A diet measured in 1 month could look completely different from the same group's diet later in the year. Hunger shaped these decisions, but that does not mean every ancient person was constantly starving. Food shortages varied across places and times, and mobile foragers could sometimes move away from local failure. The deeper problem was uncertainty. Food did not arrive with a weekly delivery window. A successful hunt created a temporary feast. A missed opportunity could mean eating the less exciting root that everyone had been politely ignoring. This is why the idea of one perfect paleo diet is misleading. Our ancestors were not following a nutritional philosophy. They were solving local problems. One group could rely heavily on meat. Another could gather large amounts of starchy plants. Others built diets around fish, shellfish, nuts, fruit, honey, seeds, or combinations that changed constantly. What humans seem especially adapted for is not one sacred ratio of meat to plants. It is flexibility. We use hands, tools, fire, memory, cooperation, and shared knowledge to turn different environments into meals. Someone has to remember which mushroom is food, which mushroom causes a terrible afternoon, where the tubers grow, when the fish arrive, and how to open a bone without launching half of it into a relative. So when you look into your refrigerator, the strangest thing is not any individual food. Ancient humans would recognize meat, fruit, eggs, roots, and perhaps the general ambition behind cheese. The truly alien feature is reliability. Your supermarket has summer fruit in winter, ocean fish far inland, and more calories in one aisle than many ancient groups could gather in days. The shelves stay still. The food does not hide. Almost nothing tries to sting you. Ancient humans ate plants, animals, insects, fish, marrow, seeds, roots, fruit, honey, and whatever else their skills could pull from the local landscape. But the real ancient human diet was not a list of ingredients. It was the ability to look at nature's chaotic, seasonal, occasionally venomous supermarket and somehow find dinner.